Look closely at what you are seeing. This is not just an old factory. This is not just metal, belts, and smoke. This is the beginning of how modern machines think. Today, we use smart machines. They measure, they predict, they decide. But here's the question most people never ask. Where did all of this really start? Because the machines we use today are not completely new. They are evolved. What you are looking at is one of the earliest industrial machine systems ever created. A system that powered entire factories, long before computers, long before software, long before automation. So how did this machine actually work, and why did it break down so often? Let's slow down and look carefully. This factory did not have intelligence, it had force. One central power source ran everything. That power came from a steam engine, or an early electric motor. From that single source, energy was sent across the entire building through long rotating steel shafts. These shafts never stopped moving. They ran above workers' heads, across ceilings, from one end of the factory to the other. Now ask yourself this: how does power move from one rotating shaft to a machine on the floor? The answer is simple: belts. Leather belts connected the moving shaft to individual machines. When the shaft rotated, the belt moved. When the belt moved, the machine worked. No software, no sensors, no safety systems, only motion. Now look closer at the machine itself. Every movement depended on gears. Large gears reduced speed. Small gears increased it. This allowed machines to cut metal, press materials, or shape components. But here's the problem. Gears create friction. Friction creates heat. Heat weakens metal. So here's the question: how did workers know when something was wrong? They didn't. There were no warning systems, no alerts, no monitoring. Failures were discovered only after damage happened. Now look at the belts again. These belts carried all the power. But belts stretch over time. They slip under load. They lose tension. So what happens when a belt slips? The machine speed changes, precision disappears, and when a belt snaps, the machine stops instantly. Sometimes many machines stop at the same time, because remember, they all share the same power system. This was efficient, but it was fragile. One failure could slow down an entire factory. Now look at the human side. Workers stood very close to moving parts. Rotating shafts, spinning belts, exposed gears. There were no protective covers. So here's a serious question. What happens when clothing touches a moving shaft? The answer is brutal. Accidents were common, hands were crushed, bodies were pulled into machines. This system produced power, but it demanded human risk. Now let's talk about control. There were no control panels, speed was adjusted by hand, pressure was judged by experience, operators listened to machines, they watched vibrations, they smelled overheating oil. So ask yourself this: can humans maintain perfect consistency for hours every day? They cannot. Fatigue caused mistakes, and mistakes caused failure. This is why breakdowns were normal. Heat buildup, continuous friction. No real-time feedback, maintenance was reactive. Something broke, then it was fixed. But here is the deeper problem. When one machine failed, others slowed down. Production stopped. Time was lost, money was lost, and industries began asking an important question: can this system be improved? That question changed everything. Instead of one central power source, machines were given individual electric motors. Each machine became independent. If one failed, others could continue working. Overhead shafts disappeared, belts became shorter, factories became safer. But control was still human. Machines could be powered separately, but they still could not sense problems. So the next question appeared: can machines monitor themselves? That is when sensors entered factories. Simple sensors at first: temperature, pressure, speed. Machines could now detect abnormal behavior. Lights turned on. Alarms sounded. This was not intelligence yet, but machines were no longer blind. Fewer workers were needed on the floor. Human roles began to change. Operators became supervisors. Now look at modern factories. Robotic arms move with precision. Machines communicate with systems. Production runs day and night. But here is the most important change. Machines no longer wait to fail. They predict failure. Software analyzes vibration, temperature, and performance data. Problems are detected before damage happens. Maintenance is planned, not forced. So ask yourself this: is this still the same machine? Yes, the structure changed, the intelligence evolved, but the core idea remained: power, motion, control. Now look at the final stage. At high-driven control rooms, dashboards show machine health in real time. Algorithms adjust performance automatically. Factories operate quietly, efficiently, almost invisibly. And humans? They observe, they analyze, they decide strategy. The machine did not replace humans, it changed their role. So here is the final question. If machines can now monitor, adjust, and protect themselves, what should humans focus on next? The old machine never disappeared. It evolved, and the future will not be built by abandoning machines. It will be built by understanding them.